Previous video, we talked about what it meant for a coordinate point to be a solution to a two-variable equation. We said that if you take the x-coordinate and the y-coordinate and you plug them into an equation, if both sides are equal, then you have a solution to that two-variable equation. If you plug in the x and y and you get an untrue statement, so both sides are not equal, then that is not a solution to that two variable equation. So this is really important for moving forward and talking about graphing two variable equations. So there are infinitely many coordinate point solutions to a two variable equation. I showed you one answer right here, but there are actually infinitely many of those solutions that will work. That's just one of them. Now, a lot of those solutions are going to be really nasty numbers that we don't want to deal with. 1, 2 is a really nice one, but there are definitely answers that like square root 3, square root 2. That would work. That would be a solution, but that's not a nice number. So there are infinitely many coordinate points that will satisfy a two variable equation. And if we're going to plot all those points, all infinitely many, it would take us an infinite amount of time, and we simply don't have that. So what we do instead is we plot a few points and we connect the dots. I want to give you the technical definition of a graph of an equation. The technical definition of a graph of an equation is that the graph is the set of all coordinate points x and y that satisfy an equation, all infinitely many of them. So it's a set of points. We see it pictorially, but mathematically speaking, the graph is the set of all coordinate points that satisfy an equation. Again, not realistic to plot all coordinate points, and we can plot a few instead. So we're going to do two different examples where we plot points and then draw the graph of the two variable equation. The two variable equation that we're looking at first is y equals 3x minus 2. This is probably something you've done maybe recently, maybe a little while ago, but you've probably done this before, where you take x values, you plug them into a y equals equation, and then you have an x and a y and a coordinate point. So to begin with, I'm going to take -2, and I'm going to plug in -2 to the y equals 3x minus 2 equation. So I have 3, and then instead of x, I'm going to put -2 minus 2. 3 times -2 is -6, minus 2, that's -8. So we have the coordinate point, -2, -8. And I can plot that point right here. Let's do the next one. I'm doing 3 times -1. That's our new x value. Minus 2. -3 minus 2, that's going to be -5. So I'm plotting a point at -1, -5. I'm going to go ahead and pause the recording while I fill in the rest of the table. I am not going to make you sit through me filling out this table. So hold on, what will be exactly a second for you. All right, so I have finished filling out my table. I'm going to go ahead and plot these points now. So I've plotted the first two. We have 0, -2. We have 1, 1, 2, 4, 3, 7, and 4, 10. And if we look at this, this looks like if we connected the dots, we'd get a line. And sure enough, connect those dots. It's a line. So there's graphing using a table. I'm going to do one more example I'm gonna, again, do the first two x values, then pause the video, fill in the rest of the table, and finish graphing. So scrolling down here, the function we're working with now is y equals x squared. So I'm going to take x equals -3, plug it into this function. So we have -3 squared, which is 9. That's going to be the point -3, 9. The next point, -2 squared, that's 4. So we have -2, 4. Right. I'm going to pause the video, fill out the rest of the table, and then we'll plot some points. Here is my filled out table. Let's plot these points. So -3, 9 is going to be right up here. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. So this shape looks a little bit different. It is no longer line shaped. But connecting the dots, we get, oh man. Let's see. Don't worry, my computer can fix, my iPad can fix any artist errors. There we go. This shape right here is a parabola, and it is something we're going to talk about a lot more in some upcoming sections. And we'll find ways to graph parabolas that don't involve filling out tables each time. But in the meantime, this is our first method of graphing a two-variable equation. So we plug in x values to the y equals equation. Then we have an x value, a y value. We put them together to create a coordinate point. We plot the points. We connect the dots. And you got yourself a graph. All right, so that is it for this video. We'll see you guys in another one. Bye.